Unit 1, Activity 7, Problem Solving with Systems. Throughout this unit, you have been using the steps in a general problem-solving process to solve real-life problems. In this activity, you will again practice the general habits of mind that are vital to solving messy real-world problems. Specifically, you will need to weed out extraneous information, create useful representations of information in order to solve a problem, document your reasoning as you solve a problem, and interpret the results. Learning outcomes. We will model data using tables, graphs, and equations, solve systems of equations using tables, graphs, and equations. We did that from the last activity, and use technology to graph regression data and find the regression line. Problem solving. Solve a word problem that's similar to those discussed in the class. Paraphrase the task and identify the relevant information. Make an estimate and check answers using another representation. Generate multiple representations to solve a problem, and of course interpret the result. And you should be able also to explain your mathematical reasoning in a clear and detailed manner so that others can follow it. And you'll be able to find the equation of a line through the points and solve the systems of equations using substitution, and you'll determine if a relationship is a linear function. Let's have a warm-up here. Find the equation of the line that passes through the points negative 8.4, negative 6.7, and 1.6, and negative 4.4. So this is very important because you need this to solve our problem for our lesson. So find the equation of the line, that is y equals mx plus b. So remember, whenever you have 2 points, so this is x1, y1, x2, y2, just to recall, you'll be able to solve for the slope, that is the change in y. So y2 minus y1 over the change in x, x2 minus x1. This is x. So let's do that. y2 is 4 minus y1, negative 6.7 over 1.6 minus negative 8.7 equal to 10.7 over 10.3, and when you divide this is 1.04. Now after you get the slope, we need to get the y-intercept b. So you can use either of the 2 points. So let's use this as your x and y and plug into your y equals mx plus b. So y is negative 6.7 equals, your slope is 1.04 times your x is negative 8.4 plus b. So negative 6.7, if you multiply 1.04 and negative 8.4, that is equal to negative 8.736 plus b, and add 8.736 both sides. And this is equal to 2.036. So now you'll be able to write your equation of the line. So y equals, your m is 1.04x plus your y-intercept b is 2.036. So this is the equation of the line. That is number 1. So again, don't forget, whenever you have 2 points, solve for the slope, y2 minus y1 over x2 minus x1, and then after that use one of the 2 points, is either the first or the second, to substitute to your x and y. Like I use here, your x is negative 8.4, so this one, and negative 6.7 here, to solve for b. And then now you'll be able to write the equation of the line. Next problem, number 2. Find the equation of the line again in the form of y equals mx plus b given the horizontal intercept of negative 4 and vertical intercept of negative 5. So what do we mean by these intercepts? Horizontal intercept of negative 4, that is when y is 0. So this is negative 4, 0. And vertical intercept of negative 5, that is when x is 0. So this is 0, negative 5. So if this is 0, negative 5, that is already your b, the y-intercept. So we already know that b is equal to negative 5. Now how do we find the equation of the line? So we can use this other point, xy, plug in that here with your b to solve for m. So y is 0 equals m times negative 4, b is negative 5. If we add 5 both sides, so this 5 equals negative 4m, then divide by negative 4, so m is negative 5/4. So you have m and b. Now you can write the equation of the line. So y equals negative 5/4 x plus b. Your b is negative 5, so that is minus 5. So this is the equation of the line. Okay, so just don't forget horizontal intercept, that is when y is 0, and vertical intercept, that is when x is 0. Alright, now let's proceed to our class discussion. Two planes are approaching an airport that is currently limiting the types of planes that are allowed to land. A twin-propeller Cessna that is 2 miles due east of the airport is instructed to head towards a holdover area 10 miles due north of the airport. At the same time, a second plane, Jumbo Jet, is the first plane. The second plane, Jumbo Jet, is 5 miles west of the airport and is being rerouted to an alternate airport that is located 59 miles east and 8 miles north of the airport. Another air traffic controller returning from their 30-minute lunch break realizes that the two planes are now heading on paths that cross each other. Don't worry, the Jumbo Jet increased its altitude so that there was no mid-air collision. Using this problem, letter A, identify the important information of the problem and create a sketch that shows the planes and the routes. Okay. So let's say that this is the airport. This point A here is the airport. Let's say this is at the origin. And it says here the first plane, Cessna, is 2 miles due east. So let's say this is 2 miles due east. This point here. So I'm going to use this as Cessna, and this is 2 miles. And it was instructed to head towards a holdover area 10 miles due north of the airport. So this is the airport, 10 miles of it. Oops, say this is, say, 10 miles. Let's say this is 10 miles. And then the second plane, Jumbo Jet, is 5 miles west of the airport. 5 miles. So let's say this is Jumbo Jet, which is 5 miles, and is being rerouted to an alternate airport that is located 59 miles east of the airport and 8 miles north of the airport. So from this airport, 59 miles. So let's say it's here, 59 miles. So let's say this is 59 miles, just an example. And 59 miles east and 8 miles north of the airport. So let's say this is 8 miles east of the airport. So this is 8 miles. So as you can see here, from point to point, so think about this is like our the airport is at the origin. So Cessna, you can say that the coordinates here are 20, and 10 miles north of it, this is going to be 0, 10. So this from here to here, given 2 points, we can write an equation using y equals mx plus b, just like what we did from the warm-up. Given 2 points, we will be able to write an equation for line. Same thing here. So let's say the airport is the origin, 0, 0, 5 miles west of the airport, so this is -5, 0. And here from the airport, 59 miles east and 8 miles north, so we could say that the coordinates here are 59 and 8. So we will be able to write the equation of this line. And as you can see, the green and the orange lines, you'll see that they will intersect at this point. So it's like we want to solve this. But before we do that, we want to find the equations of the 2 lines. So let's start with Cessna. We have 20 and 0, 10. So the slope here is 10 minus 0 over 0 minus 2. That is 10 over -2 is equal to -5. And 0, 10, that is the point on the y-axis. So your b here is a 10. So the equation for Cessna is -5x plus 10. Okay, then for Jumbo Jet, we have -5, 0, this point here, and another point here, 59, 8. First solve for the slope. 8 minus 0 over 59 minus negative 5. So that is 8. 59 minus negative 5 is 64. They're both divisible by 8, so this is 1/8. And then we need to solve for the intercept. Even this, what is this point here? So we can use either of these two. So let's use the first one, negative 5, 0, as your x and y. Substitute that to y equals mx plus b. So let's say 0 is equal to m is 1/8 x is negative 5 plus b. So this 0 equals negative 5/8 plus b. If we add 5/8 plus b both sides, so b is 5/8. So we have the slope and b. So the equation of jumbo jet is equal to, the slope is 1/8 x plus the y-intercept b is 5/8. So these are the two equations. Okay, but we have the two equations, y equals negative 5x plus 10 and y equals 1/8x plus 5/8. Now we are going to solve this system of equations like what we did from the past activity. They're both equal to y, so we can set them equal to each other. Negative 5x plus 10 equals 1/8x plus 5/8. To solve for x, since you see a denominator of x 8, the best way to do this is to get rid of 8, and to do that we multiply everything by 8. So that is like 8 times negative 5x is negative 40x. 8 times 10 is 80. 8 times 1/8x is just x, plus if you multiply 8 times 5/8 is equal to 5. And then now it's easier to solve for x. So what we do here is, if we subtract x both sides, so this is negative 41x plus 80 is equal to 5, plus x plus negative x is 0. And then we subtract 80 both sides. So now this is negative 41x equals 5 minus 80 is negative 75. And lastly, divide both sides by negative 41, so that x is equal to 75 divided by 41 is 1.829. And remember, after you solve for x, you need to solve for y. You can plug in this to either of the two equations here. So let's use the first one, the green one. So y equals negative 5 times, we are going to substitute the value of x, 1.829 plus 10. That is y equals negative 9.145 plus 10. So y is equal to 0.855. So the point of intersection, this point here, is at 1.829 and 0.855. So this is the point of intersection, and that is where the two planes will intersect. This is Cessna and this is Jumbo Jet. So at this point, but don't worry, they mentioned here that the Jumbo Jet increased its altitude so that there will be no mid-air collision. Okay, and before I end this, I will show you using Desmos. So when you type the two equations here, you have the first one, negative 5x plus 10, which is this line, and the second equation is 18x plus 5/8, so the orange, and they intersect at 1.829 and 0.854 or 0.855. So that is the point of intersection. Okay, and that's it for activity 7. Thank you.